Imagine millions of packages flowing through a warehouse perfectly, only to be stopped dead by a single unseen bottleneck. Welcome to The Explainer. Today we're diving into a fascinating intersection of disciplines. On one side, we've got the heavy lifting world of supply chain management. On the other, the highly intellectual space of distilling complex engineering research into bite-sized professional insights. And the glue holding them together? The incredible power of advanced digital simulations and artificial intelligence. We're going to see exactly how engineers spot physical bottlenecks in the real world, and then how they leverage AI to share those high-level solutions with the rest of the industry.
We've got a fantastic roadmap for this explainer. We're covering modern supply chain challenges, the power of system simulation, data-driven bottleneck solutions, strategies for optimization, and finally, communicating those engineering insights. Let's jump right in.
Section 1. Modern Supply Chain Challenges. Let's look at the massive logistical hurdles warehouses are facing today, especially with the huge shift toward large, highly discrete order quantities.
So, what actually causes a supply chain traffic jam? Well, it's crucial to understand that a warehouse bottleneck is literally just like a traffic jam on a highway. It completely blocks the smooth journey of goods from arrival to departure. Recently, and definitely accelerated by the pandemic, warehouse operations have fundamentally changed. We aren't just dealing with massive bulk shipments anymore. We're handling vast amounts of small, discrete quantities. And when your operation is suddenly bombarded by that kind of variability in order sizes, your workflows get incredibly stressed. That stress inevitably creates a traffic jam, and your operational effectiveness just grinds to a halt.
Managers are mostly facing 5 common hurdles right now: space utilization, inventory accuracy, labor management, order fulfillment speed, and adapting to technology. And the tricky part? Any inefficiency in one immediately drags down the others, hitting the bottom line hard and delaying customer deliveries. Think about it. If your space utilization is off, your labor management suffers because workers are literally walking further to pick items. If inventory accuracy drops, order fulfillment speed tanks because pickers just can't find what they need. It is a tightly interconnected web. Ultimately, adapting to technology is often the only way to break this vicious cycle.
That brings us to Section 2, the power of system simulation. To fix these traffic jams, engineers are stepping up with advanced simulation software to create a digital twin of the warehouse.
By definition, a bottleneck is a point of congestion that slows down the overall process and causes a massive concentration of goods and delays. Identifying this specific, stubborn pressure point is the entire goal of our simulation exercise. We can't just go out on the floor and guess where the problem is. By creating a virtual playground, a simulation, we can perfectly replicate the warehouse environment using real-life data. This lets us observe the flow of goods, how resources are being used, and process times, all without disrupting the actual physical warehouse. It's basically the ultimate what-if testing ground.
We actually map this problem out in 3 distinct phases. We start with a 2D, top-down layout model to spot layout inefficiencies, like weird congestion at a queuing area. Then, we step up to a 3D immersive model for realistic process flow, showing exactly how products dynamically interact with resources like cranes and pallets. Finally, we underline the whole thing with logic diagrams. That is where the real engineering magic happens. It outlines the control logic, the conditional pathways, and the decision points from the moment goods arrive to when they're dispatched. It is literally the brain of our digital twin.
Moving to Section 3, Data-Driven Bottleneck Solutions. Once that digital twin is up and running, we transition from visual models to hard, statistical data to pinpoint the exact workflow breakdowns. There are exactly 10 key indicators used to measure warehouse productivity, covering things like labor productivity, transport utilization, and picking and receiving rates. By feeding our simulation real operational data, we can track every single one of these indicators in real time. And this is the most exciting part. We are totally done relying on intuition. We are letting the raw data explicitly highlight exactly where the facility is struggling.
When we map out the timing, a very clear picture emerges. Goods are spending significantly more time waiting in inbound storage than they are in outbound dispatch. It's glaringly obvious that the intake area is the primary bottleneck. The time it takes to pull pallets into the unreserved staging area is vastly larger than the time it takes to push those same pallets out during dispatch. Boom, we've found our traffic jam.
The statistical analysis proves that unreserved areas, queuing zones, and racks are facing massive congestion, which severely delays total cycle time and order fulfillment. Because these inbound resources just don't have the free capacity to handle incoming tasks, goods literally just sit there.
This sets off a massive domino effect, inconsistent order distribution workflows, and agonizingly long waiting times for pre-orders. The data proves, without a doubt, that we desperately need better resource allocation in the receiving and sorting areas.
Which leads perfectly into Section 4, Strategies for Optimization. Now that the data has shown us exactly where the warehouse is failing, how do we physically fix it?
We can break our optimization strategy down into 4 key pillars: layout, inventory, equipment, and process. For layout, it might be as simple as relocating high-demand items closer to packing stations to slash travel time. For inventory, optimizing stock levels directly improves cash flow. On the equipment side, introducing an automated storage and retrieval system, or AS/RS, gives you faster, safer movement, drastically speeding up that inbound bottleneck we just pinpointed. And for process, upgrading your software guarantees better resource tracking. Ultimately, it's not about making workers run faster. It's about the smarter, data-driven management of space and resources.
Section 5. Communicating engineering insights. You see, fixing the physical space is really only half the battle. The modern engineer also has to effectively share these high-level logistical insights with the professional community.
This is where the digital voice comes in. We're talking about AI-driven communication generators that autonomously distill complex engineering research into professional content. Imagine you've just solved a massive bottleneck using advanced simulations. How are you going to share that breakthrough with your peers or potential clients? Writing authoritative content takes time that most hands-on engineers would honestly rather spend actually fixing things. So an AI draft generator steps in to bridge that exact gap, amplifying engineering expertise without getting bogged down in manual academic research.
This AI operates on a brilliantly rigorous specification. First, you give it a keyword input. Then, it systematically analyzes up to 100 academic publications. But here's the kicker. It executes a strict 30-minute hard stop before generating 3 targeted drafts. To put that in perspective, a human would need days just to skim that much literature. It literally searches databases, opens texts, and studies them. And that 30-minute hard stop is genius. It prevents the AI from falling into an endless loop of analysis paralysis, making sure you get rapid, timely content based on the best insights it could process in that window.
What makes this tool so powerful is how it takes lengthy, dense academic research and translates it into concise professional insights. We're talking a maximum of 150 words that are clear, structured, and totally value-driven. The AI strips away all the tedious academic jargon. It doesn't bore you with, according to recent literature. Instead, it speaks with a confident, snappy tone. It forces the content to be compact and highly readable for busy professionals who are just scrolling through their feeds.
The AI strategically outputs 3 specific formats. Draft 1 is an educational hook focusing on technical insight, ending with a clear question to spark debate. Draft 2 is a subtle pitch focusing on real-world application, gently highlighting indirect business value. And Draft 3 is the personal expert approach, tying the research back to the author's own deep engineering credibility. It is absolutely not a one-size-fits-all approach. Whether you want to start a conversation, highlight your consulting services, or cement your authority, you have a complete, ready-to-go communication toolkit.
So, from digital twins optimizing physical warehouses to AI voices shaping professional knowledge, how will your digital toolkit evolve next? As we wrap up this explainer, I want to leave you with that thought. We've seen how simulated digital twins clear the literal traffic jams in our supply chains, and how AI-driven digital voices clear the communication jams in our professional networks. The tools are here, the data is waiting, the only question left is, what are you going to optimize next? Thanks for joining me, and keep pushing the boundaries of what's possible.